चालू हो गया आओगे ए जा भी उसका चलो लेट्स कंटिन्यू लास्ट टाइम क्या किया था ऐसे इतना भी शांत करने की जरूरत नहीं है फर्स्ट वीडियो है कर सकते हैं ये होमवर्क सब आया ना वो माइनस डेल्टा एच का वैल्यू ना हाँ ठीक है डिफरेंट एंथैल्पीज भी लिख दिया था ना हमने राइट ऑन नेक्स्ट हेसेस लॉ एच ये हेसेस लॉ लिखवा है ना मैंने हाँ ठीक है वो ग्रुप पे एक फोटो डाला था हेसेस लॉ हाँ हाँ बट लेट्स अंडरस्टैंड व्हाट एग्जैक्टली इज हेसेस लॉ Now pay attention please. We've already done numericals on Hess's law, but we need to understand what exactly the law means. Hess's law क्या बोलता है? You complete a reaction in one step or you do a reaction in n number of steps. ठीक है? The amount of heat associated in the reaction will remain the same. ठीक है? So let's say something like this. Let's say we're doing C plus O2 gives CO2. ठीक है? Combustion of graphite. Now, let's say the enthalpy associated with this. ठीक है? मैं randomly कुछ भी number लिख रहा हूँ. Let's say that is 400 kilojoules. If I do the same reaction in 2 steps, C plus half O2 giving me CO, let's say the enthalpy here is minus 100 and CO plus half O2 gives me CO2. The enthalpy here is minus 300. If I sum up the reactions, I get यही वाला same reaction again. बोलो रे, yes or no? Yes. And the enthalpy will also remain the same. That is what Hess law is trying to explain. Also, you can mathematically add, subtract, just treat, we can treat equations, chemical reactions as equations and find enthalpy of reactions which are not really possible or hypothetical reactions की enthalpy भी we can calculate using Hess's law. तो ग्रुप पे मैंने एक फोटो डाला था वो पूरा थियरी कॉपी किया था ठीक है एक सम ट्राई करते हैं ऑन हेसेस लॉ पीपल ये वाला क्वेश्चन किया था कि देखो दी enthalpy of formation of CO2 H2O and glucose is so and so कर दिया है ना ठीक है right on the enthalpy of formation. How will you write enthalpy of formation? You don't have to write the entire thing. You'll write that as delta H naught of F. ठीक है? the enthalpy of formation of H2O is minus 68.3. The enthalpy of combustion of acetylene, which is C2H2, is 310.6, negative 310.6. And the enthalpy of combustion of C2H4, which is ethylene, is minus 337.2. Then calculate the heat of reaction. Then calculate the heat of reaction for hydrogenation of acetylene. For hydrogenation of acetylene at constant volume, and at 25 degrees. वो डाउट्स के लिए मीट में आफ्टर क्लास जो ऑनलाइन भेजा था ना व्हाट्सएप पे. चलो, now we will. So they've given us enthalpy of formation of water, enthalpy of combustion of acetylene, and enthalpy of combustion of ethylene. एकदम easy question है. So let's first write the corresponding reactions. How will you write the first reaction? Enthalpy of formation of water, H2 plus half O2 gives me H2O. Remember? What is the second reaction? Enthalpy of combustion of acetylene. So C2H2 plus O2 gives me CO2 plus H2O. बराबर. Balance this for me. यहाँ पे आ जाएगा 2. Correct. And 2 to the 4 and 5, and I think 5 by 2. That's balanced. ठीक है. Now what will the third equation be? Enthalpy of combustion of C2H4 gas plus again O2 gas gives me CO2 gas plus H2O liquid. बरोबर. Balance this. यहाँ पे आ गया 2, यहाँ पे आ गया 2 to the 4 to the 6, यहाँ पे आ गया 3. So these are the sub equations that we have. And question क्या बोलता है? What do we have to find? Heat of reaction for hydrogenation of acetylene at constant volume. First thing, what is heat of reaction at constant volume? Is it delta H or is it delta U? Constant volume. Delta V. Chalo. Now you have to find delta U. Okay. And what is the reaction for a hydrogenation of acetylene? What do you mean by hydrogenation of acetylene? C2H2 plus H2 gives me this is the reaction that we want. And iska we will calculate delta H, then which expression will we use? Delta H is equal to delta U plus delta nRT. And then we can find delta U from here. Delta NB equation से मिल जाएगा. I think it's already balanced. Now what is Hess's law? We can use these three equations, solve them mathematically in order to find ये वाला equation. People getting that? चलो कैसे करते हैं? What do I need यहाँ पे LHS पे? And that is in which equation? Second वाला equation. Then I need plus H2, which is there in the first equation. And I need C2H4, which is there in the, but in the third equation, it is on which side? I need to take it to, so you can do this two ways. में. या swap the equation, sign में भी change करो.
I swear.
भाई बाद में कर. So we can either swap the equation, or what we can do is you subtract the third equation. समझा?
पास करो भाई.
बाहर जा, एक पॉज कर रहे हो. पॉज हुआ क्या? नहीं, वापस चला जाता है. हाँ. So we know that we need to either swap the third equation or subtract करो. The third equation को subtract करो people. And see this O2 but हमको O2 चाहिए ही नहीं in the entire equation. तो मुझको पता है कि when we do वो mathematical calculation O2 अपने आप चला जाएगा. So if we do 2 plus 1 minus 3, we'll get this equation. Let's try. 2 क्या है people सबसे पहले? C2H2 plus 5 by 2 O2 plus H2 plus half O2 minus C2H4 minus 3 O2. That's LHS. RHS में क्या है people? 2 CO2 plus H2O plus again H2O minus 2 CO2 minus 2 H2O. सब चला गया. And what are we left with? C2H2 plus H2 gives, and that is what the equation that we were looking for. C2H2 minus रहता वो right में लेके plus कर दिया. ठीक है? Correspondingly, we also find delta H का value. So how will you get that? Equation number 2. Equation number 2 का delta H क्या था people? Minus 310.6 plus minus 68.3 minus the third equation, which is minus of 337.2. Solving this will give you delta H. बोलो रे. How much is delta N? How do you find delta N? Number of moles of gaseous products minus number of moles of gaseous reactant. How many? What is number of moles of gaseous product? 1 minus 2. So that is minus 1. How much will you use R as? 8.314. And what about temperature? कितना दिया है? So that is 298 Kelvin. You can use that and find. I'll tell you. Did you will get that? जल्दी जल्दी. साथ में उसको pause कर दे. Sure, let's continue. And last part of the chapter, and probably the most important part of the chapter. ठीक है, जो आधे से टाइम कुछ समझ में आएगा नहीं. ठीक है. Please write down spontaneity and spontaneous processes. People, we have written limitations of first law of thermodynamics. Limitations लिखा है क्या? नहीं लिखा था ना? We have not written limitations. ठीक है, चलो. Right now, limitations of इसके अंदर लिख सकते हो. इसके अंदर लिख सकते हो. Limitations of the first law of thermodynamics. Limitations of the first law of thermodynamics. Float, or the first law of thermodynamics, does not give any information. Float does not give any information about the extent to which change taking place. It does not determine the feasibility. It does not determine the feasibility of a process or its spontaneity. Does not determine the feasibility of a process or its spontaneity. It is unable, next point, it is unable to predict. It is unable to predict the direction of change. It is unable to predict the direction of change or feasibility of a process in a particular direction. Feasibility of a process in a particular direction. चलो, ठीक है. I'll explain this along with spontaneity, and then we'll also do second law of thermodynamics, and then eventually entropy. आज के लेक्चर में theory कर लेंगे. Next class will only be numericals, that is tomorrow. सबसे sorry. Now, so we need to understand what do you mean by spontaneity or a spontaneous process. I think we've done this before. Anyone remembers what's a spontaneous process? A spontaneous process is a process which happens on its own, or it may require initiation, but then once you initiate the reaction, it will happen on its own. A reaction is something like which happens on its own. Like example लेते हैं. Let's say I have a hot cup of tea, वो लाके मैंने इस room में रख दिया. That hot cup of tea will eventually come down to कुछ initiate करना पड़ा क्या? No. It happened on its own. It's a spontaneous process. But now you want that room temperature T to again go back to that hot temperature, क्या करना पड़ता है? You need to again supply that. Will that body absorb that heat from the surrounding automatically? No, ऐसा नहीं होने वाला. So the reverse of that becomes a non-spontaneous process. So a non-spontaneous process is a process which does not happen on its, and you need to continuously supply energy for it to take place. एक और simple example लेते हैं. Let's say I bring a cube of ice and I keep it in this room. Eventually it will become water. So that from ice to water, it was spontaneous. It happened on its own. Did you initiate anything? अपने आप जलता है वो. Spontaneous process. You want to go back? क्या करना पड़ेगा? You'll have to freeze that. Yes or no? What kind of process is that? Does it happen on its own? No. Now, majority of all irreversible processes are spontaneous in nature. So we are trying to find a condition. What makes a reaction spontaneous? Yeah, why some reactions are spontaneous? Let's take one more example. Let's say when you burn coal, you need to initiate that burn. एक बार initiate किया, then that keeps on burning on its own. Yes or no? So some spontaneous process उसको initiate करो तो अपने आप हो रहा है. Why such processes happen on their own or are spontaneous? We are trying to find a criteria for that. Many examples. Water from a higher level it flows to lower level. सबके building में tank top में रहता है, नीचे क्यों नहीं रहता है? Because water will flow from a higher level to उल्टा नहीं होता है. उल्टा is a non-spontaneous. So what makes certain processes spontaneous? We're trying to find reason. The first reason everyone tried was, is spontaneity related to enthalpy? What is enthalpy? Heat. For example, they were trying to find, जैसे कि ice becoming water. Ice is absorbing heat from the surroundings. So when ice is becoming water, ice absorbs heat. So is this an endothermic process or an exothermic process? It's an endothermic process. बराबर. डेल्टा एच पॉजिटिव है यहाँ पे, बोलो रे. Yes. But at the same time, let's say we take the same cup of tea wala example. Hot ice, hot tea, so not hot ice, is becoming room temperature wala tea. Is this exothermic or endothermic? Exothermic. Heat is being released surroundings. Are both the processes spontaneous? Yes. But can I link spontaneity to enthalpy? What I'm trying to say is, can I say all spontaneous processes are exothermic? No. No, not all. Some spontaneous processes are endothermic. So spontaneity and enthalpy ka direct relation. You cannot say that all spontaneous processes are endothermic or all spontaneous processes are exothermic. No, you cannot have a direct relation. वो criteria fit नहीं होता. And that is why we have a new criteria. And that criteria is defined as entropy. Now what is entropy? वापस से बर्फ. We have ice. Okay, let's say this is that cube of ice. At room temperature, this will first turn to what, people? Water. Okay. And then from water that turns to vapor. Entropy says that over here the water molecules were in a perfect aligned structure. What happened here when ice turned into water? क्या होने लगा? Was that structure थोड़ा सा broken? Did we disturb the structure? And when you go from liquid to vapor, इधर क्या हुआ? Structure all. Entropy says that as a process becomes more spontaneous, it becomes more random. Randomness increases as a process becomes more and more spontaneous. An increase in spontaneity is directly proportional to an increase in entropy, and entropy is randomness in a system. And it's applicable everywhere. Think about this. ये classroom में, if I leave this classroom for 2 minutes, all of you are very quiet. शांत बैठे रहते हो. You don't talk to each other. Do you ever do that? एकदम शांत बैठ रहे. No. You start becoming more and more random. You're never organized. Unless there is an external energy present trying to control you people, you are always spontaneous. एक कॉर्नर से दूसरे कॉर्नर में बात करने की कोशिश करते हो. So entropy is everywhere. Randomness is everywhere. कल के पेपर में क्या होने वाला है पता है क्या? It's all I know क्या होने वाला है, but मार्क्स तो रैंडम नहीं है. पिछले WIT के अपने मार्क्स रैंडम नहीं आ रहे, बट so everything is random. Why? Because everything is trying to become more and more spontaneous. Why is the universe continuously expanding? Because it wants to become more and more spontaneous. Hence randomness in the universe is increasing, and entropy is also continuously increasing. Did you people get that? Yes or no? Sure. Right on. नहीं वो कुछ लिखा अभी तो. Spontaneous processes, कुछ नहीं. Spontaneous processes take place. Spontaneous process takes place on its own or may require some initiation. On its own or may require some initiation. Most spontaneous processes are exothermic. However, there are a number of processes. However, there are a number of spontaneous processes. Which are endothermic. And hence enthalpy cannot be a sole criteria. Enthalpy cannot be a sole criteria to decide spontaneity. And hence we introduce entropy. And hence we introduce entropy. Bracket में write on the symbol capital S. Capital S. Next point, entropy is a measure of randomness in a system. Entropy is a measure of randomness in a system. Randomness is uncertainty in a system. Randomness is uncertainty in a system. Or the different ways in which a system can be arranged. Or different ways in which a system can be, in which we can arrange a system. Different ways in which we can arrange a system. Entropy is a state function. That is, we cannot find its absolute value, but we can find change in entropy. But we can find change in entropy. It is an extensive property. It is an extensive property. What do you mean by an extensive property, people? Depends on the amount of matter present in the system. It's an extensive property. Unit. यूनिट कॉपी कर लो. Next point. For a non-isolated system, the entropy change of both system and surroundings is to be considered. कॉपी करो बोर्ड पे जो लिखा है. चलो ना, so let's say people we have a reversible process, and let's say in a reversible process ठीक है, system absorbs Q amount of heat from the surroundings. ठीक है, I repeat, I have a reversible process in which system absorbs Q amount of heat from the surroundings. So the entropy change will be given by entropy change of the system. Delta S system will be minus, I'm so sorry, heat is absorbed, so it will be plus Q reversible upon T, या let's say we say dq amount of heat is absorbed, तो इसको हम क्या लिखते हैं, dq upon T, तो इसको हम ds भी लिख सकते हैं. ठीक है. So if system absorbs heat from the surroundings, the surrounding will lose that much amount of heat. So how will you write the expression for surroundings minus dq reversible over T, and what will be the overall change? डेल्टा एस टोटल क्या लिखेंगे हम यहाँ पे, सब डी डी में लिखा है, तो कैन आई से दैट विल बिकम 0. बोलो रे यस और नो. Now from here we will ds is equal to dq upon T. Can I write that T ds system is equal to dq reversible? समझो क्या क्या, बोलो रे. Now people give me the first law of thermodynamics. According to first law of thermodynamics, delta U is equal to Q plus W. In place of this, or can I say dq is equal to du minus dw? I can substitute that here. So what do we get? TDS system is equal to du minus dw. With me till here? What is the expression for work? Minus PdV.
But it was for irreversible process, no?
उसको अगर मैं सी वर्क तो PdV ही होता है, इंटीग्रल PdV. Whether it is reversible or irreversible, the expression can be applied for both. बराबर. सिर्फ क्या पता है, यहाँ पे हो जाता है V1 to V2. इरिवर्सिबल V से प्रेशर इज कांस्टेंट, तो P बाहर आ जाता है, इंटीग्रल dV is V2 minus V1. बट वहाँ पे क्या करते हैं, प्रेशर इज नॉट कांस्टेंट, प्रेशर कीप्स ऑन चेंजिंग, तो P की जगह हम लिखते हैं nRT by V. But the initial expression remains same, PdV. समझा? And for du people we can write n CV dt, which is heat absorbed at constant volume, plus PdV. ये किसका एक्सप्रेशन बन गया? TDS सिस्टम. Now divide throughout by T. What do you get? ds system is equal to NCV dt by T plus P can be written as NRT. I don't know, समझा कि नहीं समझो. P को we wrote as NRT by V और ये TT कट हो जाएगा. So can I write this as NR dV by. This is the expression for ds system. Purpose I am writing the expression ds system is equal to, give that expression again people, NCV dt by T plus NR dV by, integrate this, yes or no? What is integral 1 upon V, 1 upon x dx, 1 upon t dt, 1 upon t dt and 1 upon v dv का इंटीग्रल क्या बन जाएगा? ln of x. So this will become ln of t, directly लिख दूंगा t2 minus t1 which is t2 by t1 plus this will become nr ln of v2 by, and that is the expression for for ideal gas P1 V1 over T1 is equal to P2 V2 over, so can I say V2 by V1 is P1 by P2 into T2 over T1 is V2 by V1. Substitute this over there. What is the expression? Delta S system will be equal to NCV ln T2 by T1 plus NR ln, instead of V2 by V1 we can write P1 by P2 into T2 by T1. Open this. NCV ln T2 by T1 plus NR, I am writing ln T2 by T2 by T1 first plus NR ln P1 by P2. Do you see something common over here? N ln T2 by T1. We left with CV plus R plus NR ln P1 by P2. What is CV plus R? CP plus CP minus CV is equal to, so I can write this as, so NCP ln T2 by T1 plus NR ln, that is another expression for जो भी बॉक्स किया है, those expressions are very important. हाँ. Delta U, sorry, delta H is equal to delta U plus delta NR T, divide throughout by delta T. What is delta H by delta T? Change in enthalpy at constant pressure को हम बोलते हैं CP, CV plus NR, assuming number of moles to be equal to 1. ठीक है, next. चलो, now for different processes, which is the first process? Iso. What is an isothermal process? Change in temperature is 0. If delta T is 0, delta U is also, then according to first law of thermodynamics, dq plus dw will become equal to, therefore dq will be equal to minus dw. What is the expression for work? Minus 2.303 nRT log of V2 by V1. माइनस माइनस क्या हो जाएगा वो प्लस. इट्स अ रिवर्सिबल वर्क, इसलिए ये फॉर्मूला लिख रहा है. Therefore, what will be delta S system? We know that delta S system is dq upon T. How much is dq? 2.303 nRT log of V2 by V1 upon T. T cut हो गया. So what is the expression for enthalpy change for a system for an isothermal process? 2.303 nR log of V2 by V1 या nR ln of V2 by V1. This is which process? Isothermal. Next. Isothermal का क्या था? Iso. What is isochoric? Delta V is, which means work done is, which means dq is equal to du is equal to ncv dt. Same चीज वापस. What is delta S system का formula? dq by t. This will become ncv dt by, इसको अगर इंटीग्रेट किया, therefore delta S system will become ncv ln of t2 by isochoric. Isochoric के बाद isobaric. What is isobaric process? What is isobaric process? Delta P is 0. Therefore, delta S system is Q reversible upon heat absorbed at constant pressure is, delta H का expression होता है NCP. Therefore, delta S system here will become NCP ln of T2 by T1. And the last process, कौन सा है? What is adiabatic? No, heat exchange. Q is equal to, if Q is 0, delta S system will be, this is called as isoentropic process. There is no entropy change in an adiabatic reversible process. कार्तिकी की एंट्रोपी इनफाइनाइट हो गई है. Did you will get that? हाँ, साथ तक इसको पॉज कर दे. ओह पाटिल पॉज करा. चलो प्लीज राइट डाउन. Gibbs free energy right on. Delta S system can be calculated. Delta S system can be calculated, but delta S surrounding is very difficult to calculate. And hence delta S total and hence delta S total cannot be calculated, and hence delta S total cannot be calculated. So enthalpy and entropy. So enthalpy and entropy are not sufficient. Enthalpy and entropy are not sufficient to determine spontaneity. Enthalpy and entropy are not sufficient to determine spontaneity. A new next point. A new thermodynamic function called as Gibbs energy. A new thermodynamic function called as Gibbs energy is required. Now pay attention, people. So Gibbs energy G is equal to H minus Ts. We remember this equation H minus Ts. WIT पिछले WIT का first question था ये. ठीक है. G is also a state function. What do you mean by state function? And is an extensive property. What do you mean by an extensive property? ठीक है. Does not depend. It depends on the amount of matter present in the system. Therefore, ठीक है, at constant temperature, we can write this expression as delta G is equal to delta H minus T delta S. अब ये कहाँ से है people? We can write the same thing. G2 is H2 minus TS1. G2 is H2 minus TS2. Subtraction temperature is constant. I'm not writing all that. हम सिर्फ इतना लिख रहे. Did you people get that? This is called as Gibbs Helmholtz equation. ठीक है. Now people, we know that delta S system is equal to heat absorbed reversibly at constant temperature. Patil idhar dhyan de. So delta S system will be equal to, so TDS, T delta S system will be Q reversible. Okay. We also know that delta U is equal to Q plus W. Which law is this? Delta U is equal to Q plus W. First law of thermodynamics. Or we can say that Q reversible here will be delta U minus, this W can be written as, sorry, Q minus W, which is delta U minus of, so that becomes delta U plus P delta V, and this is what Q reversible. But we also know that delta H is equal to delta U plus, so RH is same, so we can say that delta H is equal to, which know that, or Q reversible is, so we get delta H is equal to T delta S system. समझ यहाँ तक? Any questions? Next, we know that delta S total is equal to delta S system plus delta S surroundings, or I can say delta S system. If system absorbs heat, it will absorb heat from the, so if system gains heat, surrounding will, so that becomes minus Q ReV upon T. But we've just proven that Q ReV is delta H. Therefore, delta S total is equal to delta S system minus delta H upon T, multiplying throughout by T. So T delta S total is equal to T delta S system minus delta H. Any questions still there? थोड़ा सा यहाँ पे, can I write this as T delta S total is equal to, I'm writing this first, minus delta H plus T delta S system, or I can say minus T delta S total is delta H minus, anyone who did not get that, compare that with do you see some similarity? RHS पे क्या है यहाँ पे? डेल्टा H minus T delta S, ये भी सिस्टम है. It's okay. Therefore, delta G is minus T delta S total. Why is this expression important? Because if delta S total is greater than 0, which means entropy is increasing, then we say that a process is spontaneous. But delta G is opposite to delta S. So if delta S is positive, delta G will be, so for a spontaneous process, Gibbs energy should be negative. Ulta, if delta S total is less than 0, delta G will be greater than 0, such a process will be non-spontaneous. And if both are 0, then such a process is at equilibrium. With me? बोलो रे. हाँ बोल रहा.
Here we proved कि delta H is T delta S system में.
हाँ
If वो अगर उधर डाले तो zero नहीं होगा delta G.
यहाँ पे डाला था ना.
हाँ.
हाँ हो जाएगा तो 0. ठीक है. नेक्स्ट. We know that delta G is delta H minus T delta S. Purpose say for a process to be spontaneous, delta G should be negative. For a process to be non-spontaneous, and if it is 0, delta H can either be endothermic or it can be entropy of a system can be positive, or entropy of a system can be entropy of a system can be or entropy of a system can be. Out of the 4 possibilities, there is one possibility where a process will always be spontaneous. Can anyone identify such a process where I want my process to be spontaneous? What will be the criteria for delta H and what will the criteria be for delta S? I repeat, I want my delta G to be less than 0. What will be delta H and what will be delta S so that it is always spontaneous? If delta H is negative and delta S is positive, into this negative is going to be, and delta H ka value is also, what does that tell you? That delta G value will be less than
0.
This process is spontaneous at all. Give me a criteria where the process will always be non-spontaneous. Second, if delta H is delta S is negative, into this negative is going to become, which means delta G will always be greater than 0. In short, non-spontaneous at all temperatures. What about in this criteria? What is delta H? Delta S is also, but we want spontaneous process. So I'll have to increase the, so this is spontaneous at high temperature. Now what about here? Delta H is negative. Delta S is also negative. So negative into negative is going to become, but I want delta H to dominate. Why? So that my delta G remains negative. So this is you will get that. Pause कर दो. Oops. Chalo. Now, write down second law of thermodynamics. So let's first understand why do we need second law of thermodynamics. Okay. So let's say people, let's say we have a block on some surface ऐसा, ठीक है, moving at a velocity of hypothetical velocity 5 meters per second in this direction. Eventually the block will come to why? Because of friction. Yes or no? Work here in the form of kinetic energy is getting converted into heat energy, right? So friction के वजह से there will be heat. And let's say some hypothetical heat, 25 kilojoules of heat is generated in this process. If I supply back that 25 kilojoules of heat, वो block पीछे जाएगा? मतलब, did you get that? No. You supply that 25 kilojoules of heat, it will only increase. Excellent. The internal energy of the block. What is second law trying to tell? Ki work can be converted into energy. Vice versa. There is some or the other loss of energy. For example, steam engine चलाने के लिए what do we provide? Coal को heat करते, that converts it into steam. So coal का total energy is getting converted into, and that is used to perform work. So the energy that we supply to the steam engine वो पूरा work में convert होता है क्या? नहीं, what happens? There is loss of energy to the surrounding in the form of heat. In short, if you take some amount of energy, use it to produce something else, there will never be 100% efficiency. समझ में आ रहा है? वो लॉस किधर गया? एंट्रोपी बढ़ाने में जाता है. In short, always remember that the difference is what increases the entropy. समझा? Yes or no? So write down. States that it is not possible to convert heat. It is not possible to convert heat completely to work in a cyclic process. There are various statements. We're going to write various statements. Next, we cannot construct an engine. Physics में किया ना, Carnot's engine. We cannot construct an engine which converts heat. We cannot construct an engine which converts heat completely into work. Next point. Only those processes occur spontaneously. Only those processes occur spontaneously in which the entropy of the universe increases. In which the entropy of the universe increases. Next point, when the value of entropy is, when the value of entropy increases, when the value of entropy increases, the ability to do work decreases. Last point, the ability to do work decreases. Last point, float deals with conservation of energy. Float deals with conservation of energy. Slot deals with direction of flow of energy. Slot deals with direction of flow of energy. We still have to do numericals and a very small part, which is the third law of thermodynamics. We will finish the chapter tomorrow. ठीक है?